Hi, welcome back to another Calman tutorial. My name is Marcel and I'm with Portrait Displays, and I'm very happy to introduce a very new display today to you. It's the Xencelabs Pen Display 24 Plus Studio Series. What is that? It's a digital drawing screen, and as you can imagine, digital artists that are using those drawing screens are part of a collaboration and a content creation workflow. So what you want to do is you want to make sure that the display you're using, in this case our 24 Plus drawing screen, is actually looking correct and has the same correct color showing as all the other teams that are working in a specific color space. The beautiful thing here is that it's the very first Calman ready drawing display, which means that our Calman calibration software can directly talk to the Xencelabs Pen Display 24 Plus. And that means that we make the lives very easy of the artists because they don't worry about calibration in the first place. They worry about their art and making sure that the creative intent stays intact. So we're going to show you today how to calibrate it and how easy it is, because it's actually as easy 1, 2, 3. I have already connected the Xencelabs Pen Display 24 Plus with our laptop that's running Calman calibration software. All you need to do is connect it with a USB-C cable and you're done. It's actually that easy and simple. The other thing what I have done is I connected our C6 HDR 5000 colorimeter also with the same laptop that's running Calman, because Calman now will take over the control of the display calibration as well as controlling the meter to take the readings from the screen and also loading the test patterns that we need to actually run the calibration. So let me get started here. So the first thing is we start the Xencelabs workflow, and that's actually very nice because we created a workflow just for the Pen Display 24 Plus. And so you see Calman loads the workflow, and as soon as it's loaded, you see that it's a wizard and it's guiding you step by step through the calibration process. So even if you've never done it before, we make it as easy as possible so that you don't really have to have a lot of guesswork going on here. So I click Next, and the first layout here is the hardware setup. So you see that we have to connect to the meter, which I already positioned in the center of the screen. We always read from the center of the screen because in terms of uniformity and everything, that's normally the best location to put the meter. Now I'm going to skip step 2 for just a moment and come down to step 3, pattern source. You can see we actually don't need a pattern source. Calman is taking care of the pattern generation automatically, so we don't need any kind of pattern generator or pattern source for this workflow, which just leaves step number 2, connecting to the Pen Display 24 Plus. So let's get started. I click Find Meter, and I say Search, because you see Calman is supporting a lot of different meters. Now in our case, we're using our own C6. And now Calman is connecting. You see it starts to blink, the LED is flashing, and now we see it is properly connected. And as soon as we connect, you also can see in the top right hand side, you see there's the meter tab, and it already says Portrait Displays C6 HDR 5000. The next thing is we're picking the right meter mode. That's what we call a meter mode or a meter profile. That's one of the powerful things in Calman. So what we do is we have all those dozens of different meter profiles that are based on different display technologies, right? And so in this case, we have created one meter profile that's optimized just for the Xencelabs Pen Display 24 Plus Studio Series. Why is that important? Well, normally you would use a spectroradiometer or something if you don't know the light source and if you want to calibrate something to a specific spectral response of that panel. Now we know it already, and we did all the work for you in our R&D lab, and so we created a profile for that panel technology, put it in Calman, and Calman is controlling our meter, and that makes sure that you get the highest precision readings that you can imagine with the C6 HDR 5000. Isn't that neat? Yeah, that's pretty cool. So I'm going to pick Xencelabs Pen Display meter profile. All right, so as soon as I have done this, and I say Find Display, and you see, the thing is, what I want to do is I want to look for Xencelabs. And then I have only one model, and it's that monitor that we're supporting, the 24 Plus. And I say Connect. So we're connected. And you see, it now says display connected is the Xencelabs. And by the way, just as a little side note here, if you're using an external pattern generator, an external pattern source, make sure that this source is running in SDR, so that means standard dynamic range, not HDR mode, right? That's very important. So we're all set. We click next. And here we can now pick our calibration targets. So you see there are all sorts of different targets you can use as a calibration target. Those are the typical color modes in which content creation normally happens. And this is very much depending on what your working color space is, for example, or what your project is all about, right? So in this case, just for this tutorial, I'm choosing sRGB, or which is also ITU BT709, which is the HD TV standard, basically HD color, which is still the mostly used color standard these days, although there's HDR and 4K and all of this out there. But in our case, we're picking now the 709 sRGB color space. And when we pick it, we also will see that Calman is already recommending you the right gamma formula and the right white point, which in this case would be D65. And so that is the typical setup you normally would want to have in combination with the Pen Display 24 Plus. The neat thing here is that the panel gamut itself, the native gamut, is about 99% of Adobe RGB, which is a very big color gamut. And so what we're doing in the calibration process, we're calibrating a 1D LUT for Grayscale and a 3x3 color matrix to get the BT709 or sRGB color exactly at the point where it belongs. Because we can do the color math, the color signs, and put basically in the calibration process, create exactly that color gamut for sRGB ITU BT709, which lies inside basically from the size of the bigger Adobe RGB. Of course, you can also do an Adobe RGB calibration if you want to, but since there's one mode that can be calibrated, you would need to calibrate either for Adobe RGB or for sRGB slash BT709. So you see, color space now is set to Rec 709 sRGB. Gamma formula is a power function, it's 2.2. If you're working in video, you probably want to do 2.4 or BT1886. That depends again on your project. We'll leave it like this here now. And then the white point is set to D65, which is basically X3 12.7 and Y coordinate is 0.329. So we also make life easy for you, so give you the right setting right away. We click next. And so the first thing is we're going to do a pre-calibration measurement, which means we're measuring the display state when it comes out of the box, or in this case, we're measuring basically the color mode, custom mode that is now loaded. And that's going to be important because to create a 1D LUT and to create the 3x3 color matrix, we need to profile the display, which means we're now taking the reading, and then after that, we're starting the calibration process. So I click measure. So here we go. The pre-cal measurements are completed. You see that we still have a couple of color errors here that on the scale of the delta E scale are going beyond 5 or higher. So just as a reminder, you normally want to be in an average of about 2 as a color error on the delta E scale. If you go higher, it's pretty obvious that some of the colors are not correct. Everything around 2 or lower is very hard to see for the human eye. So this is why in the calibration process, we will now get the panel exactly where it belongs. So to do that, I click next, and you see the first thing is we do a display reset. So that means any kind of setting, any kind of thing that probably was still in the memory of the video processor is going to be reset back to the original factory state. And after this, we can start the calibration. All right, so the display reset is accomplished. Now we click next. And you see here, we can check the display luminance, the peak luminance of the display. So for example, if I click measure, it shows you how bright actually the display shows its peak white. Now we are around 335 nits or candela per meter square, which is the same unit. And since it's an LCD panel, an IPS panel, we can change the backlight here with the backlight control. Now, what kind of luminance do you want to set? I think this is pretty much depending on where you work with the drawing pad, the drawing screen. It's also pretty much depending on what the color standard is you're working in for your project. So there are a couple of things that you might want to take into account. So we'll leave it just as it is for now, and pretending that this is what we want to use, and click next. And this is the layout where we start to first calibrate the 1D LUT. So to do this, I click the AutoCal button, and you see it's opening a window that allows me now to pick the amount of grayscale points that are going to be measured, then on which the LUT calculation will then be based. So in this case, we have 11, 17, or 21 points. Now for this tutorial, we just leave it with 11 points, and we see the delta E target we set to 0.5 on the delta E scale. And all we need to do now is say, okay, let's go. So what you also can see is at the top right side, you see it says virtual LUT enabled. So this is our Aurora color engine and the LUT engine that is building the LUT in the background. So it's kind of a virtualization of how the RGB triplets would be corrected. In the end of the overall calibration process, we will actually measure the LUT in a real validation workflow so that we make sure that the LUT that was built for Grayscale and also the color matrix for the color gamut are both correct. So we will then do this in the final validation stage. But in this case, we'll see how the LUT is basically built in real time. All right, so you see the full Grayscale calibration is completed, so it gives us this little information window that pops up by building and profiling the LUT. So we're done with this, and it looks pretty awesome already here. We will have a final validation later. We click Next, and here's now the part where we calibrate the 3x3 matrix, the color matrix. So I click the AutoCal button again, and you see we already show your optimized predefined values and the setting you want to actually use. So it's like the stimulus level, the measurement points is 75%, and the delta E target, again, we keep it at 0.5 delta E on the delta E scale. If we're happy with this, we say yes, go, and it will do its magic. All right, so again, we get the information here. The full gamut calibration is completed, and it was just a minute, and total reads 10. And now we're good to go and get to the next and final stage where we will do a final validation. Again, we can check the luminance here. So if I take a reading, you can see we had 335 nits. Now we have 324 nits. So we lost about 10 nits, which is not really much in the calibration process. So let's see what the final result is. So you see we have our post-calibration measure layout. That means we're going now to measure the display. We really measure the real LUT that we loaded into the display and make sure that this is exactly as we expect it to be. And after that, I show you the calibration report. And as you can see, it looks superb. I mean, we have now a Grayscale average delta E of 0.5. The max is 1.7. This is exactly what we said. We want to get it below the 2 delta E of 2 threshold, because that's what you don't see anymore with if you don't have a golden eyes. And then we have average of 0.5 for the color checker and a max of delta 1 in color. That looks really amazing. So just imagine, now finally you can have a pen display 24 plus within your production workflow where other people are using screens that are similarly calibrated and they're doing the editing or they're doing the color grading, but your artists are going to see the same thing, and everybody knows that the preservation of creative intent is always top-notch. So finally, we can create our calibration report. So you see in the final layout, we can say, well, I want to restart the calibration because I maybe wasn't happy with the results. No, in this case, I'm super happy with the results. So I think, hey, yeah, let's save the session and let's create a report. And so we can save the session, give it a name. Now, in this case, I would just say today's date, including, we say that's the Xencelabs 24-inch. And we did the BT709 color or sRGB. We say save the session and generate me the report. And here you see, on the first page of the report, we can see the pre-calibration measurements. So this was the state of the picture mode, factory-based. So you see, and the same for the Grayscale. So it was a little bit too blue. It was a very wide color gamut. As we said, it's about 99% of Adobe RGB. And after the calibration, we can see that we got it exactly where we want to have it. Like it's a 0.6 of average grayscale and it's a max of 1.8. And you see the grayscale looks absolutely beautiful. And also the color space is now 0.4 of average color delta E, and we have a 0.7 max delta E on the delta E scale. This is how we would like to have it. You also have some space for additional calibration nodes if you want to take those. And well, as the final stage, we generate a report and we export it as a PDF. Why is this nice? Well, maybe you have a director, or maybe you have other artists that are working with you and you want to show them that your drawing screen is calibrated on a regular basis, so you can then show that calibration report and everybody has peace of mind that everything is set up correctly, as an example. In this case, we just give it a name. We say that's the Xencelabs 24-inch sRGB or 709 mode, and we say store it on the desktop for me as a PDF. Thank you very much. Well, that's it for today, folks. You see, it's super simple. Please let us know what you think about this tutorial and give us some comments. Otherwise, we're going to see you in one of the next Calman tutorials. Have a great day. Bye.